This is a guy, Dan Lanowski, I believe his last name is Lanowski. He's from Michigan Soil Works, and he has come up with a new continuous flow-through bin that I believe is top of the line. I've got a better picture in a second here. So Rhonda has the Vermiculture conference every year. If you all are interested in worm composting, in October of every year, and we go out and visit the composting facility that she has, but you can learn a whole more than you would ever want to know about worms if you go to her conference, and I really like going to it. I've been there for 3 years. And this,
is there a website regarding that?
You can also Google Vermiculture Conference. It's like the only one in the world. So it's a 2-day event. Troy spoke last year.
Yeah, she's got a whole lot of resources on there. She's got another way of building your own worm bin at home. There's multiple things on there. You can go and check that out at another time, but it's a good resource to have as well. So for the large continuous flow-through bin, you want to feed it every 2 to 3 days as well. You want to mist it daily. Most people have some type of irrigation unit set up where they've got pipes over their continuous flow systems and then have misters every few feet. And then you can harvest this once a week, and I'll show you how to harvest in a second here. There's a picture. And then most of these, like the one I have shown here, come in 5 foot by 8 foot units, and a 5 foot by 8 foot unit produces about 5 cubic feet per week. So Dan and there's another one called the Worm Wigwam. Sustainable Agriculture Technologies is who makes this other one. They're in Oregon, is it? But all the commercial ones come in 5 foot by 8 foot lengths, and then you can get 16 feet, 24, or however many you need. And then people also will build their own, like out of warehouse, the pallet racks. Like when you go to Sam's, the racks that you buy stuff on, you can engineer one of those and turn it into a flow-through bin. Okay, this is from Rhonda's composting facility. This is the inside of one of the Sustainable Agriculture Technology worm wigwam things. The reason I have this picture is to show the bottom of the unit. So you've got a screen here that is 4 inches by 2 inches. I think that 2 inches by 2 inches would probably work better. And from the experience I've heard from other people, I believe that's true. The main reason I'm showing this picture is because it can be a little bit difficult to see this, but you've got a piece here that's called the cutter bar. So it's this, that's all together. And then it's very hard to see, but it's connected to a chain, and not a chain, but a cable and a winch. So there's a winch at that end, and there's a winch at this end, and that winch pulls that cutter bar across. The idea is that the cutter bar runs across. You guys in the back can't see that. Here's the bottom, sorry about that. This is the bottom of the bin. The bar runs across the bottom, and the angle of the bar cuts about the 2 bottom inches, and then that drops out the bottom. So then you would take like something like a broom or something like that and pull the material into a pile to collect it. How many of you have heard of the Johnson-Su bioreactor? Okay. Rather than me telling you what it is, I'm going to play the YouTube video. I think I mentioned that at the beginning of the presentation. I'm going to play the YouTube video just so that you can see, for those who haven't seen, you can get an idea of what it is. We'll talk about why it works, the goods, the bads, and then we'll go out and talk about that. And then the rest of the afternoon will be spent on compost tea. So I'm just going to flip ahead in their video and tell you what they're doing. What they do is to take a pallet, a regular 4-foot pallet, drill a hole in the center of the pallet, and then they have 5 holes. So they cover the pallet with landscape cloth, and then use 4-foot cattle fencing, that's the 4-inch one, and make a 4-foot diameter circle out of that, and then cover the inside of that with landscape cloth. And I believe that they use landscape cloth just to keep the materials in. I was explaining to somebody else that if I were to do this, I would probably try, maybe he has tried this, but I would want it to be more breathable, and so I would use a hardware cloth. But I imagine he has his reasons for doing this, because I think he's spent a lot of time researching how to put this together. So that's what it looks like when he's laying out the pallet. Here it is covered with landscape cloth. They're securing it to the pallet. They have rebar things to hold this in place, to hold PVC pipes in place. So these are, I believe, 4-inch PVC with holes drilled in them. And they're going to position these in those holes that you saw cut on the bottom of the pallet. And then this rebar is going to keep them positioned once the material gets filled into the whole reactor here. Like that. And you can see they've got ropes on them here. And the ropes are going to be to pull and draw the tubes out of the material once it gets packed in there. So they take wood chips. I believe he's mixing some leaves in here too. And soak 24 to 48 hours. And the idea is that you want to get the wood chips that you use nice and moist. Like I had described before about misting your ingredients, especially with wood chips. Wood chips aren't going to necessarily absorb the water. So if they were to soak in water, you're going to get nice penetration of that moisture into the material, which is going to aid in decomposition and aid in the microbes coming in to break it down. And this is just a couple of minutes of him turning the stuff with water. So then they fill the reactor. So this shows them filling up the whole reactor, filling it up, packing it down. And then here, after they have the whole unit filled up, I believe they wait a day to a few days to kind of let it settle and get packed into place. And then they come along, and this is him standing on a platform. Here's a couple of the tubes that's already been pulled out. And then you can see the rope standing up from those 4-inch tubes that is getting drawn out from the material. And so the idea behind this space where the tubes are is that you've got these columns of nothing where the air is going to go down deeper into your material in the reactor, and you're going to have more airflow, and it's going to be more aerobic, and you've got the more aerobic pockets, and it's going to help it to breathe better. So then they put drip irrigation on here. You can see the drip emitters are blue here with the irrigation in a circle. For the incoming irrigation is in the circle there. As far he covers that top. Then once he gets the drippers on, he's got a piece of landscape cloth that he puts over the top. And then they don't go into a lot of explanation for this, but then after, I believe it's 4 weeks, they take red wigglers, and I think, if I remember correctly, he uses, I didn't get a chance to re-examine the video before the conference today, but I believe he uses like 2 pounds of red wigglers that he then introduces into this. It's about a ton of material, and lets the red wigglers work for another 2 weeks to 4 weeks to process that material down farther. And then, so according to David Johnson's research, he has been working with soil food web stuff and realizing that we need to get more fungi in the soil. And it's been his goal to produce compost in a way that we're getting more fungal dominant compost. And that's what I was explaining in the beginning, is that we're always trying to get more fungi going and get more fungal dominant compost to get more fungi in the ground. He has found that he gets fungal dominant compost by this method, and he was able to use an application rate of 1 ton per acre with this compost and have an effect on the biology in the soil to where he's changing the biology of the soil. And when they're doing future tests on the biology, they're seeing more fungi and bacteria and everything of the soil food web in the soil. So you're getting life back into your soil. And I don't know how many of you have spread compost, but a ton of compost on an acre, you're not even gonna see that. It's like drops in the ocean. So to be able to use 1 ton per acre is you're gonna be able to save a lot of money on materials. So I see some pros and cons to this. And there was a gentleman I was talking to over the lunch there who's doing this on a larger scale, because in my opinion, I really like the results of this. But for someone who's got more material to compost, or many acres to cover, I don't know if this is necessarily that scalable, because you have a lot of energy going in with these pallets and landscape cloth and tubes and then having to buy worms. And in my opinion, I'm not saying this is the way it is, but I just see that I don't see how you would do it on a super larger scale. I don't see him in here, but there was a guy that said that they figured out a way to do it on a bit larger scale. And so it is being done. Just to me, there are other ways that are more energy efficient and efficient for materials, like where you're not having to spend so much money. But anyway, so Dan, who had to leave early, has been doing he's taken the materials that he's got to use and tried to do a Johnson Sioux style bioreactor. So when we look at the one outside, it's not going to be exactly like what you're looking at here, because Dan's been trying to take, like I said, materials that he has. So they have extra totes, they've got wood chips, they've got of wood vinegar that comes from their biochar process, and they're trying to take advantage of all these waste products and use what they can to do what they can with what they can. So just expressing that when we see what's out here, it's going to be a little bit different than what you're seeing up here. And he's noticing that he may not get the same results because I think that he may need some more airflow with what's out here. But we'll discuss that on our way out to the brewer. We're going to go check out the brewer after the compost tea presentation.
I'm having a hard time understanding when you till, you break up the fungus, but in this situation, you're taking the fungus and spreading it very thinly on a bunch of ground. So it sounds like the fungus has a lot of capacity to spread on its own, even if it's broken up.
Yes.
So I'm not like, I don't think tilling's a great idea, but I just think I'm a little confused as to why that might be.
Yeah, so the idea, when in the soil, you're going to have strands of fungi, but you're not going to have necessarily a lot of mycelium that's built up and built up and built up. For any of you who have how many of you have grown mushrooms to eat or grown mushrooms in any way? So you know that like you buy either spores or inoculated spawn, thanks, and you're using that spawn to inoculate more material. And in that same way, the spawn that you have, so you've got these little chunks that are tons of microscopic hyphae on top of each other that create mycelium. And so it's a matter of, like throwing one person into the lions versus throwing 100 people into the lions. Does that make sense? So when you're tilling, you've got like just single strands that that aren't necessarily clumped together. And when you're using a compost like this to get biology out onto the soil, in terms of fungi, you're going to be having like little clumps and more, although it's very small, more mass of fungi going out that will then grab onto the soil residue and what's in the soil and use that as food to then extend out into the soil. Does that clarify more what you're asking?
I'm getting there. So.
Okay. Yeah.
More concentrated?
It'd be like more concentrated. Yes.
You said there were better ways, less expensive ways to get more fungal compost into the soil.
Her question was, I had said that there were more inexpensive ways to get fungi into the soil. What I was trying to get at was that there's more inexpensive ways to make similar compost, like the aerated static pile that I was showing you. It really all comes down to your starting materials and how you're managing it. So I worked with a guy in California who does worm compost, and worm compost, because of the nature of it and because of the nature of worms and the microbes that are in their guts, is normally bacterial dominant stuff. But his starting materials were coming from not necessarily old growth forests, but very old forests that were parks. He happened to have a contract with one of these parks that had really old logs that were being cut down. So these old logs are full of fungi because fungi are in all types of, not just in the soil, but in plants as well. And so this material, the starting material, had lots of fungi to begin with. And normally, you're going to get fungal dominant compost by starting with fungal dominant starting materials. it can be very hard to grow. So my whole intention since I started doing this was been to get more fungal compost, and it's just proven difficult. And that's why this system that he's come through to show that he's consistently getting fungal dominant compost, it's great biologically. It just seems like a lot of work to me, whereas maybe, what if you had twice that amount of compost that was a little bit easier to manage? You had twice the amount of compost that had half the fungi, but it equals the same amount of fungi that you're spreading out, but it's easier to manage. So you're not doing as much work, because it just seems like a lot of energy to have to go into wetting your wood chips down, moving the wood chips around, building this circle, putting the poles in, pulling the poles out. Like, I don't want to spend all the time doing that. I've got other stuff to do. But taking the extra time, I think that a lot of people don't understand this, is that taking the extra time you can with any compost to make quality compost with quality biology is going to be saving you time in the long run. Because once you get good biology in the soil, if you can keep that biology going in the soil, you're going to be a lot better off. Because the idea behind that, and this is a whole different class, is that you've got living soil where you want to maintain it with cover crops that are, like I said, with photosynthesis. Plants are going to be photosynthesizing sunlight, turning it into energy that they're pumping into the ground. So plants, there's different figures that you'll hear, and I've heard anywhere from 30 to 70%, and it depends on the plant as well and the environment, but up to 70% of the sugars that are created through photosynthesis in a plant are sent out through the roots. So the majority of the energy that the plant's making, it's not using, it's sending out to feed to other things, to feed the microorganisms in the soil that are going to then be bringing nutrients back to it. And so it's a matter of having that life in the soil and getting life in the soil through quality compost. So your good quality compost is going to add not only microorganisms, but organic matter. And then by using cover crops, you're going to be the cover crops year round and having living roots in the ground year round. You're going to be continuously feeding your soil and soil microorganisms through plant exudates. And then by having residue from the termination of those cover crops, so microorganisms in the soil will first go after their preferred food source is root exudates. And their second preferred food source are crop residues. So they're going to be feeding on living root exudates and then also the residues from your crop or cover crops. So that was kind of a long spiel there, but it was just kind of spending the time to make compost and use compost correctly is going to save you a lot of time and energy later on. So if you can put more work into it in the front end, like with a lot of other things, if you can put a little bit more work in the front end the first year or two and get good biology going, you're going to be spending less time later on pulling weeds, adding fertility, spending money on irrigation and all kinds of things like that.
So the brown layer, if I can get it on my property, I can get from the forest the dead trees, instead of wood chips, I can just get the part of the tree that's already a nursery for fungi. I can take off the outer layer of that tree and use it for the brown layer. Yeah.
Yes. If you have a tree that's down in the forest, you could take some of that. Yeah. Or like people do hugelkultur, which is burying logs and big sticks underneath the ground and then adding materials on top of that. And the idea behind that is to get fungi going on those. That's going to build soil structure and get biology going underneath the ground there to help build soil and get living soil going. Also, if you were to go and grab stuff from the woods like that, you just want to make sure that you're not grabbing stuff from a tree that appears to have been diseased and died from a disease, because then it's most likely some type of fungal disease that has made the tree, right, yeah, and you don't want to be grabbing those.
Question related to that. If there's a blight that's bacterial in a tree, and then the limbs or the tree itself, you chip, you have the root chips and you compost those chips, would the temperature kill the blight?
Yeah, especially with bacteria, the high temperatures should kill those pathogens that are in there, yes. As long as it's in the core of the pile and getting heated up to above the 131. The question was, if you had a bacterial disease in your woody tissue that you were using to chip up to use in your compost pile, would the heat from the compost kill those? And I was saying yes, that the heat from the thermophilic process should take care of the pathogen, the bacterial pathogens. That is the end of this presentation.